Today we shall be dealing with this idea of the law of conservation of energy. Now, in the previous class we were discussing the ideas of the different types of energy. We talked about mechanical energy, which can be classified into kinetic and potential energy. We also talked about the other types of energies like light energy, electrical energy, geothermal energy, sound energy, and we discussed that how various devices or various elements in our daily life as well as in nature convert one form of energy to another as a part of their activities. And energy during that time I mentioned can neither be created nor destroyed, it only gets converted from one form to another, and that is basically the statement of the law of conservation of energy. This statement says that energy can neither be created nor can it be destroyed. All that can happen to energy is that it can get transformed from one form to another. So what was chemical energy can become electrical energy, what was electrical energy can become sound energy, and so on. Now, this law of conservation of energy, how can it be proved? As per your syllabus, there are two situations in which the proof of the law of conservation of energy is discussed. One of the situations is any object, in this case a ball, that is dropped from a height h, and we analyze its motion at different positions of this journey until it reaches the ground. And then there is a second scenario where a pendulum, a simple pendulum, swings from its mean position to its extreme position and back. So these are the two cases we are going to discuss. Now, as I said that the conservation of energy principle states that energy can neither be created nor destroyed, which basically means that the total energy of any system remains constant at any time. So in this case, the system is the ball, and the total energy of the ball will remain constant at any instant of the motion. So I have divided the motion into three different points, point C, B and A. C is when it is at the greatest height above the ground, point A means it is at the ground level, and point B means it is somewhere between C and A, not exactly at the halfway point but somewhere in between. So at C, what is the energy that the ball has got at C? It has got a gravitational potential energy mgh. Mg represents the weight of the ball and h is how much above the ground level the ball is placed. And we discussed that the potential energy a body possesses by virtue of its position is its gravitational potential energy. So this is the gravitational potential energy of the ball at the point C, and the kinetic energy is equal to 0, because kinetic energy is half mv squared, and here the ball is just released from rest, so it has got no velocity. At the point A, that is when the ball is just reached the ground, that is just before falling on the ground, at this point the potential energy is 0, because now h has become 0, it has already travelled the distance h. So though it has got the weight mg, because h is 0, the final product is 0. And the kinetic energy k, which is equal to half mv squared, is equal to mgh. Now how come kinetic energy becomes mgh? Well, here we have to use the formula of the equation of motion, that v squared minus u squared by 2a is equal to s. Now the final velocity of the ball at A is unknown to us, so v squared minus u square. What is u? U is the initial velocity that the ball has, and initial velocity at C is 0. So v square minus 0 by 2 times A. A here stands for the acceleration due to gravity g, and the displacement is the total height h it has travelled. So from there we get that v squared is equal to 2gh. Now substituting this value of v squared in the formula for kinetic energy, half mv squared, we get that kinetic energy turns out to be mgh. So this is the reason at the point A, the kinetic energy has a value mgh. Now what about some intermediate position like B? The potential energy of the ball at B will be its weight multiplied with the height by which it is above the ground. So the distance between the ball at position B and the ground is h minus x. So U is mg h minus x. And what will be kinetic energy? That's again half mv square. Now we have to find out what is the velocity of the ball at the point B. We again use this same equation, v square minus u square by 2a equal to s. So v unknown to us, u is 0 and acceleration is g. Now the displacement that the ball has undergone is x. This is the distance it has already travelled. So v square becomes 2gx. Substituting this value of v square in the half mv square equation, the kinetic energy at the point B turns out to be mgx. Therefore, the total energy E is kinetic plus potential energy, that's mgx plus mgh minus mgx. So that is again mgh. Therefore, by simply using the equations of motion we are already familiar with and using this adjoining diagram, we can show that at the different positions of the ball when it is in motion or when it is in free fall under gravity, the total energy of the ball always remains constant, that is mgh. At the topmost position kinetic energy is 0 and at the lowermost position the potential energy is equal to 0 because it is at the ground level. And somewhere in between, like at point B, it has got both kinetic and potential energies, but they are not equal to 0 or not equal to any fixed value. Rather, based on how much distance it has travelled, we have to evaluate the values. But ultimately, when we add the kinetic and potential energy values, we find that the total energy again turns out to be mgh. So this is one of the basic proofs of the conservation of energy principle that's in your syllabus. In the next video, we will be talking about the graphical representation of this and the simple pendulum case.